everyone, and welcome to the week 3 session of Introduction to Biostatistics live class. And we'll just wait for 5-10 minutes to see if anyone else joins, and then we can start with the session. Okay, so I guess my voice is clear, and we'll just start with this session now. Welcome everyone. I am Prashasti Pandey, PhD scholar and PMRF fellow from Department of Botany, Banaras Hindu University. And we'll be proceeding with the third live session for this course, that is Introduction to Biostatistics. And for anyone who has joined new, in this course, we will help you practice with the previous year's assignments that you can solve the sessions. We will go with some concepts that the question requires for us to solve the answer. And if there are any doubts or there is anything that you want me to tell you to understand the concept better, please let me know so we can also include that. And also, we won't be covering the questions that are included in this year's assignment, but yes, solving these questions will definitely help you solve this year's assignment. So let's go ahead and we will have one question one by one. And if you guys know the answer, I'll give you like 2 to 3 minutes of time. If you know the answer, you can either speak up or you can write in the chat box. Otherwise, I'll go ahead with telling the answer. So here is our first question. It's an easy one. Find the range of the following data, and the data set is given. So I'll give you 2-3 minutes. If you know the answer, you can speak. Also, if you want, you can write your answers in the message box, in call messages. And also, if you attended this previous live sessions, we have solved a similar kind of question of finding the range of the following data.
So 98 is the
98.
Uh,
Okay, so but you see that's not an option.
and yes, ma'am, but the calculation is and
Okay, so it's not that difficult. You would not need a calculus for this, but let's go ahead and solve this question. So, so first, to solve this question, you need to know that what range is. So range is a very simple formula. So the range of any data set will be a maximum value and subtracted by a minimum value of that data set. So now the step one to solve this kind of question would be to arrange your entire data set in some form of order. Okay, so you can either arrange it from highest to lowest or from lowest to highest. You need to arrange it, and that will help you find out the minimum value and the maximum value. So now when you see that this data set is arranged here, according to this, the maximum value is 128 and the minimum value will be your 94. Correct? Okay. So now if you apply this formula that is given of range, your equation will be 128 minus 94. Okay. And that will give you the answer as 40. So to this question, your answer will be fourth option, which is 40. Okay, you don't need a calculus or this kind of, it was a very simple question. You just need to find the range of the following data. Now let's go ahead with the second question, which is on your screen. This is you need literally pen and pencil to solve this question. So to determine the number of cells in a cell suspension, random sampling was performed and cells were counted. Given below are the numbers of the cells obtained from the sample data, and you have a data set. Now you have to determine the standard deviation for the given sample data to its approximate nearest integer. Go ahead and solve this question. You have to find the standard deviation of the given data set. Your options are 30, 10, 11 and 12. You will be easily able to solve this question if you know the formula for standard deviation.
my guess 11 is the correct answer. My,
So we have one answer 11. Is there anyone else who wants to answer? Okay. So let's go ahead and understand this question. So let's first talk about what standard deviation is. So standard deviation is nothing but it is a measure of how spread out your values in a data set is. Okay, so spreading out of a data set means that if you have some certain values and if you plot it, you will have a mean value. Okay, which will be a sort of average value of all the data sets. Now either your data could be spread in a long difference, so that means that there will be a lot of data which will be away from the mean. Okay, or there could be a data which is very close to the mean and the deviation is very less. So this point is very less for it. Okay, so now this is what your standard deviation explains. Now there could be two standard deviations, low standard deviation or high standard deviation, which basically means how much variability your data has. So if you have a high standard deviation, that means your data is more variable. uh, you can understand it by understanding that more variability means the data will be spread further away from the mean value, which was in this case. And if your data has less variability, it will be very close to the mean value, which is of this case. Okay, so this is the basic meaning of standard deviation. Now this is a simple formula for standard deviation, where it is, so xi will be your individual values, x bar is nothing but the mean value. Okay, and n will be the number of values that you have, and by this formula you can calculate your standard deviation. Now so you can understand the meaning of standard deviation if you take it in live examples. So if we are saying that the average weight of the infants is say 3 kg and the standard deviation is 0.2 kg, that means most of the weights will lie from 2.8 kg to 3.2 kg. That will be the range of your data set when we say that standard deviation is 0.2 for an average of 3 kg. Okay, so this is basically the example of how you what you understand from standard deviation. Now with our question, so let's just calculate this. So this is our given data set, okay, that we have in our question. So first we will add sum up all these things, okay, and the sum, so if you have calculated the sum, the value will be 296, and the total number of values is that n will be the number of values in your data set. So in this case we have total 10 values, okay. So now to calculate x bar, so because in the formula you need to calculate the mean first, right? So to calculate the mean value, you will there is a simple formula for calculating mean. It will be equal to the sum total upon n value, which is your 296 divided by 10. Okay, so this value will be your 29.6, which will be your x bar value. So it is 29.6. Alright, now if you put all these values in this, your standard deviation will be equal to square root, and also for this you need to do the summation, okay. So because when you need to find this entire value, so this entire value you can calculate simply by subtracting all your individual values minus the mean value. So you will have to create a table like this. So this is called as calculating the deviation. So like if your individual value is 15 and your mean was that we calculated in our previous slide, that our mean value 29.6, so you will subtract 15 from 29.6 and you will get a single value, and when you will square that value will be, and add summation of this total value will give you the answer of sum of squares. So in this case the sum of squares will be 1084.8. okay, this is the sum of squares value. Now if you put all of this in your equation, so your formula will be standard deviation equals to square root of 1084.4 upon 10.1, which was your previous value, and if you calculate this value it will be approximately 10.9. okay, so in the question if you see here, it was asked to the nearest integer, so your answer to this question will be 11. okay, so yes, correct, the answer to this question was 11. Now let's move ahead with the next question. A survey reported that the average commute time of employees in an office is 30 minutes. Given that the standard deviation is 5 minutes, determine the minimum percentage of employees that have a commute time between 25 and 45 minutes. Okay, you can start solving this question. Remember you have to calculate the value in percentage, which is given on your screen: 33.4, 66.76, 88.9 and 99.9%. This is a little tricky question. You need to know the concept of solving this kind of questions. Okay, so I'm just underlining the data that has been given to you. You just first need to figure out that what kind of data is given, and then you will be able to solve the question. So here we have one is average value given, which is your 30 minutes. Then you have the standard deviation value given, which is 5 minutes. And then you have a commute range. It is a range value of 25 to 45 minutes. This is the three important data that you have from which you will be calculating. Okay, so now let's go ahead and solve this kind of question. So now to solve this question, there is a theory which is called as Chebyshev's theorem. Okay, it's Chebyshev's theorem. So now according to, or also it is called as inequality theorem. Okay, so now this theorem, it states that for any kind of data set, regardless of its distribution, so it can be either normal distributed, skewed, or any other kind of distribution. So regardless of its distribution, the proportion of values that lie within k standard deviation of mean is at least 1 minus 1 upon k square, and for which k should always be more than 1. Now let's try to decode what this sentence says. Okay, so um, let's take an example of our question only. So what it is saying that for the average value of 30 minutes, okay, the range which is 25 to 45 minutes, so how many, what kind of data set or what percent of the entire data set's value will fall from 25 minutes to 45 minutes with a standard deviation of 5 minutes. Okay, so this is exactly what our question, what this theorem states, that it will help you understand that what values will lie within the k standard deviations. So k standard deviation is a small range. Okay, so that can vary from, so if you have k standard deviation can be suppose 1k, okay, or it can be 2k or 3k. So when you have multiple k's of standard deviations, so how many datas will lie in your 1k or 2k or 3k? That is how you will determine whether the values, so basically what it, this theorem helps us to guarantee that how much of your data will lie within this standard range. So for example, if I am saying that your k value is 2, so we need to calculate the k value first. I'll tell you the formula of how to calculate this. But suppose if your k value is 2, so by using this formula, you are getting a value of 75%. Okay, so this means that the entire data set range that you have, 75% of that data will lie within 2 standard deviations of the mean. So whatever standard deviation value you have, if you multiply it, if you take 2 times the standard deviation value, within that range, 75% of your data will lie. This is explained by the Chebyshev's theorem. Now let's go back to our question. So our question gives us the value of mean, then it gives us the value of standard deviation, and then we have a range of 25 to 45 minutes. Now how to calculate the k value? Okay, so k value is calculated by limit minus mean upon standard deviation. This is the formula for k. So if you put all the values here, so your limit should be the highest limit, which is your 45 minutes here. So if you put this value, you put 45 minus your mean value is 30. So it will be 45 minus 30 divided by your standard deviation is 5. So it will be 5. If you calculate this, your answer will be 15 by 5, which is equal to 3. Okay, so you have a k value of 3 now. Now if you use that theorem's equation, your value will come 1 minus 1 upon 3 square into 100%, because your answer requires a percentage value. So you will need to calculate a percentage value. Now if you solve this entire equation, you will get an answer of 8 by 9 into 100%, and this value will equate up to 88.89. Okay, so your answer should be 88.89. Okay, so that is your answer. So this means that whatever data set that this this survey has reported. So out of that, 88.98% of the data will lie between the so that data value will lie between the 25 to 45 minutes value. That is that many the employees are almost commuting between the 25 to 45 minutes value that the data is saying. So your correct answer to this question will be 88.9. This was a little tricky question. I hope it is clear. And we'll just move ahead to next question. Okay. So your next question is, the average number of focal adhesions in a cell were determined to be 30 in a study. If these measurements had a standard deviation of 10, what is minimum percent of cells that have focal adhesions between 20 to 50? So again, this question requires a similar formula that I explained in the previous question. I hope that you will be able to solve this question. So please go ahead. It will be helpful for you. See if you can solve this, otherwise I'll help you solve it. I'm highlighting the values that they have given.
Ma'am, 75 percentage.
Okay. If anyone else wants to answer, please go ahead, otherwise I'll solve it. I've written the values for you people on screen. It should be very easy. You just need to put it in the formula. Okay. So now let's try to solve this one again. So first of all, what we need to do is we need to find a k value, and your k value will be the highest value, which is your 50, minus the mean value divided by standard deviation. So it should be 50 minus your 30 divided by your standard deviation is 10, and this answer will come as 2. Okay, so your k value is 2. Now if you put this in the equation of the theorem, it will be 1 minus 1 upon 2 square into 100%. Okay, so this will be 1 minus 1 by 4 into 100%. Okay, and this value will be 3 by 4 into 100, and the answer will be 75%. Okay, so I hope, yes, very good. The answer is 75%. I hope this theorem is clear now. You just need to remember this formula. Okay, this one and this one, of how to calculate k and how to calculate the theorem's equation from that. Okay, so the answer to this question is 75%. Okay, great. So let's move ahead to next question. A researcher is plotting her obtained data with appropriate error bars. The standard deviation in her experiment was found to be 10, and the standard error of mean was found to be 2. What is the sample size used in her experiment? So again, to solve these kind of questions, you need to know the formula. I'll give you some time if you can solve it. Okay, so let's solve this. So now there is a new term. This is the relation between standard deviation and standard error of mean. So now there is a new term in this. Standard deviation we have already understood in the previous one of the previous questions, and now there is a new term here which is called as standard error of means. Now what is standard error of means? So basically it measures how much of the sample mean will vary from the population mean. Okay, so basically it will tell you that how precisely your sample mean estimate that we have calculated is. If you remember that we gave a similar kind of statement in the standard deviation, that what will be the variation in the data from the mean, and here again we are saying that how much of the variation will happen from the mean in case of your sample mean to the population mean. So now two different terms are being used, there must be some difference in the meanings of it. So now to understand it in very simple terms, basically your standard deviation will explain how spread out your individual data points are. Okay, so if it does not really specifically talk about whether it is your standard deviation talking about a sample size or whether you are talking about the standard deviation of population. Okay, so regardless of that, it will explain you that whatever data set you are providing, how much spread out that data set points is. But when you are calculating a standard error of means, then you are talking about the estimation that you have made based on the sample size. Okay, so if you are calculating a mean value of some sample, okay, and you are estimating it on the base of this data, you are estimating it for a population. So now your standard error of mean will actually talk about the difference of means that you have calculated for the sample and for the population, and how much chances of error are in that. So that is the basic difference between your standard deviation and standard error of means. That in deviation you do not talk about your sample size or the population size, but your standard error will compare the differences of the means or the variation of the means between your sample and your population. So now if you go back to the question, the values that was given was your standard deviation and your standard error mean, and this is your equation that I have told that you can use to calculate this. And now based on this, if you put the values in this question, so your SEM value was 2 and your standard deviation value was 10. Okay, so now you need to find out the number of data sets, the number of values in the data sets that she has used. So now it is very simple, you just need to solve this equation. So it will be 2 equals to 10 upon root n. So your root n will be 10 upon 2, which is equals to 5. So your n value will be 5 square, which is 25. Okay, so the answer to this question was 25. Okay, so option D is correct. Okay, so it's the basically the questions are very easy, you just need to know the formula to solve these kind of questions. Okay, so we'll go ahead to next question. The average blood glucose level in a healthy male after fasting is 85 plus minus 15 mg per deciliter. A patient suffering from type 1 diabetes was found to have a blood glucose level of 120 mg per deciliter. Find the Z square and comment whether the observation is an outlier or not. Okay. Okay, you can only solve this question if you know what z square value is. So let's just talk about that. So let's first understand what a z square value is, or it is also called as a standard score value. Okay. So your z square will basically tell you that how many standard deviations a data point is from the mean. Okay, so if you remember the previous question that we have solved of understanding the theorem, so in that also we talked about this, that k number of deviations, so the value, how many values will lie from k number of deviations from the mean. So here also, so in this case that, so that when you calculate this kind of value, it will basically help you standardize some value or compare these kind of values when you're talking about different data sets or different kinds of distributions. Okay, now why, and so basically this is the formula of calculating a z square value, and it is again very simple. When you calculate a z square value, you need the mean, the data point that you have, the mean of the data point, and the standard deviation of the data point, and with this formula you can calculate a z square value. Now what kind of interpretations you can make from these kind of things? So if your z score is 0, that means that the value you are getting is exactly as the value of your mean of that data set. If your data set is +1, that means your standard deviation is above the mean. If it is in minus value, then it means that your data set is, the value of the data set is below the means. Now depending on whether it is -2, -3, -4, in that case, that many standard deviations away from the mean your value lies. Okay, so now why is it important to calculate a z square value? So now suppose uh, these are some values in your data point. Okay, so now I am saying, and this is your mean value. Okay, now I am saying that there is one value which lies one standard deviation far from the mean. Okay, and then there is another value which lies, suppose, three standard deviations far from the value. Okay, now when my entire data is alongside the mean value, by knowing the z score of this particular data set, you can basically predict whether if data set is an outlier. Okay, so when you calculate a z score value, it basically helps you to identify the outlier. So usually when the z value is more than 2 or 3, in that case that particular data set value is considered as an outlier. It means that 2 or 3 times of your standard deviation, that is how far that particular data lies in your entire data sets. Now with this kind of values, you can also compare from different distributions. So if you're talking about anything which includes different distributions, so suppose you're talking something about a population, say from India, something about a population from some African country, and some population about some US country. Okay, so one single data set will help you tell about whether how far that data set is basically lying. Okay, it can be very close to me or it can be very far from me, and that will help you compare values from different distributions. So this is also how your z score value can be used. Now to use, also it can be, it can help you identify, whether the distribution is normal or whether there is a probability from a normal, for a normal distribution. I'm sorry, Krishnendu, did you raise your hand or was it by mistake?
On the board, according this rule, this is outlines that option does not match.
Oh, you're telling me the answer.
Yes, ma'am.
You're saying option C is correct.
Yes, ma'am. But it is not an outlier. But Z value is 2.34 means that greater than 2 or 3, then it is an outlier. So your option does not.
Okay, So basically, okay, so let's first solve this question and then we'll. So your doubt is basically that you are saying that it is between 2 and 3. So your option should be that it is an outlier, right? Is that your question? Did I understand it right?
Yes, ma'am.
Okay, okay. So let's solve this question and then we'll come back to this point. It's actually a very good question. So okay. So this is the values that is given to you. You have a mean value which is 85, then your standard deviation value is 15, and your observation value is 120. Now you simply have to put these values. So the basically your to calculate the z score, your equation is z equals to x minus mu upon standard deviation. Okay, so now if you just have to, it's very simple. You just put the values 120 minus 85 is your mean upon the standard deviation is 15, and if you simply solve it, it is 35 by 15, which is approximately 2.33 or 34, I think. Okay, so this was very simple to solve. Now about your question, um when you decide the range, okay, so now that so this range when you so when I was telling you about the equation, so if you see here, it is said that usually more than 2 or 3. It is not saying that it should be between 2 and 3. It is said that usually more than 2 or 3. Now to decide whether it should be 2, 3, 4, 5 will depend on what kind of data you have. Okay, so there are certain kinds of data where the distribution will be huge. um, Okay, let's just try to figure out that what these kind of datas will be. So if you so okay, if you talk about whether the leaf the average leaf size on a tree. Okay, so in these kind of examples, if a single plant will have 10 leaves, there is much chances that the variation in that kind of data set will be very less. Okay, because the plant will have similar kinds of leaves. If you count, say 10 plants, if you count the average length of leaves from 10 plants, sticking to the point that all the leaves are the first leaves that come to the plant, your variation in that data will be very less. Okay, so in that case, when you're trying to find an outlier, your outlier range, the z score range will be very less. That could be maybe 2. Okay, so if any value is giving a z score value of more than 2, you can consider it as an outlier. But if you are dealing with some kind of data set which will have a large kind of variation, so for example in this question, it is talking about type 1 diabetes which has a blood sugar level of 120 mg. Okay, and your average is 85 plus minus 15. Now type 1 diabetes, basically it can not the data will not be very limited to 120. It can even 180, 190, 200, 250 values will also be considered as the impact of type 1 diabetes. Okay, so your variation in this kind of data will be huge. So now again, if it would have been your experiment, then you were the one to decide what kind of range you will set for the data that you are dealing with. It is very similar to when you calculate, if you're in science and if you calculate the p value for uh, for stating whether your data is significant or not, and you choose the value as 95% of for acceptance, then that is you as a researcher who has decided to go for the value of p should be more than 0.05. Okay, so there are different acceptability ranges that you can go for depending on how variation your data will create. Okay, so if in this case this kind of data can have much more variation, and it can deal with maybe more than 3, more than 4 also. But coming back to the question, the correct way to answer this question is of the options that you have and depending on that. So if this particular question considers 3 as a z score value above which your data is an outlier, then in that case you are getting an option as 2.34, and which option aligns with that it is not an outlier. It would be a very difficult question to answer if you had another option which said that 2.34 and plus that it is an outlier. In that case, your question would have been, your doubt would have been very impactful, and in that case we would need some other information in the question itself to answer this kind of question. Either they would have mentioned that the range that they are considering is 3, 4, 5 or whatever, depending on what the answer is. Okay, so that is why you, based on only this amount of data that you have in this question, it will be very difficult to decide the range above which it should be considered an outlier or not. So in this question solely your answer depends on what z score value you are getting. Okay, is it clear? I hope I was able to answer your question.
Yes, ma'am.
Yeah, but it was a nice question. Good. Okay, so we will move on to our next question. Okay. So see, that is exactly what the interpretation is. That it did not consider it as an outlier, but the value is relatively high. So it may indicate that it is deviation. The data value is deviated from the normal, from the mean of the data. But then if they have set the range as 3 or 4 or whatever, we don't know that actually based on this question. So if that is the case, then it is not considered as an outlier. Okay, so the answer to this question is 2.34 and is not an outlier. Okay, so your next question is the area under the curve for a normal distribution is. Okay, this is a theoretical question. It should be easy to answer.
Option C is equal to 1.
Okay, yes, correct. So this was a very easy question, that area under the curve for normal distribution is equal to 1, because when you're talking about the area, it is always considered as the total. Okay, so whatever the distribution, the normal distribution graph will have, the entire area will always be considered as a total, and the total will always be equal to 1. Any portion or any part of that will be part of 1, and it will always be less than 1. So the correct answer to this question is 1. Right. Okay. So this was a theoretical question. Now let's solve one more, solving question. 500 people were screened for oral cancer in a cancer awareness drive. Given below are ages of diagnosis of the individuals who tested positive during the screening, and you have a dataset value. Calculate the values of first quartile and the interquartile range for the same. And you have four options to this. Yeah. I'll give you some time to solve this question.
Ma'am, option A 3424.
Okay. So we have one answer. Let's try to solve this. So there were two terms which was asked in this question. One was first quartile and the other one was interquartile range. So what are these quartiles and what is an interquartile? So when you have a data set, and if you divide, so quartile is basically 4. Quartile means 4. So if this is your data set, and if you divide this data set into different parts, you can have Q1, Q2, Q3 and Q4. Okay, and then you will have a interquartile range. So now, so basically your Q1 will represent the first 25% of your data. Okay, and also it is also called as the lower quartile, and it will always lie between your range's minimum value and the median value. So whatever data set you have, if you remember from the previous class how you calculate a median value, it is the exact middle value of your entire data set, and your minimum value will be the lowest value from your data set. So basically your Q1 will be somewhere between this range of your entire data set. That is how you calculate a Q1 value. Now the question is, what is interquartile value? So your interquartile value will be the difference between the third quartile and the first quartile. So you need to calculate a Q1 value and a Q3 value for this, and the difference will be interquartile range or the IQR value. So now IQR, basically your IQR value, so whatever if this is your data set and your Q1 is here, Q3 is here, if you see that this entire data will come under the IQR value, which also translates to saying that it measures the spread of the middle 50% of the data. See, this is your data which is ranging from here to here, and this is the middle portion. Middle 50% portion of your data will be considered under the IQR value, which basically it is making the measurement of your variability more robust. So it is a measure of telling how much variation your data has, and it will, so it is very less sensitive to outliers as compared to standard deviation. If you have a kind of data set which has a lot of variability, in that case standard deviation is not the right measure to go for, because your standard deviation can vary a lot depending on your outliers. So if no matter if your entire data is ranging between this, and your if you remove the outlier, maybe your standard deviation is 0.2, but just because of one outlier, it is lying so far from the mean, your standard deviation can go from 0.2 to 0.8. Okay, and this can make all your values, all your data sets maybe not significant. So that is why you need to know that for what kind of data, what kind of tests you should be using. So if your data has a lot of variation and it has a huge amount of spread in the data, then instead of going for standard deviation, it is better to go for an interquartile range, because it also talks about the variation in the data but is less sensitive to the standard deviation. Again, because if your value is lying here also, the middle 50% value will always be here only, and because it considers the median value instead of mean, median is not very much affected by the outliers. So that is why IQR is a better option to go for. Now to solve this question, we need to calculate the Q1 and the Q3 values, and we will go step by step to solve this question. So very simple. First you need to arrange all the values of the data set that is given, and in this case we have 11 values. Okay. Second, you need to find the Q1, Q2 and the Q3 for this. So again, as we told that the way to find out Q1, you need to know the n first, and in this case your n value is 11, which is an odd value. Okay, so now if you calculate the if you have an odd value, it becomes easier to calculate the median for this, and in this case the median will be the sixth value. So from here, if you take the sixth value, it will be 48. Okay, so your Q2 becomes 48. Okay, now we need to calculate the first quartile for this. Okay, so now for calculating the first quartile, it should be the value. So now when we were talking about this Q1, you see that it is the difference between the minimum value and the median value. So when you have arranged here, your minimum value was 28 and your median value was 48. So now if you put this data, the value between this data, the center of this will be your first quartile. So center will be the third value, which is 34. So in this case, the Q1 will be 34. Okay. So now we have a Q2 value and we have a Q1 value. Now we need to find a Q3 value, which is the third quartile. Okay. So now your third quartile value. Okay. So third quartile value will be the median value of the upper half. So again, your median value was 48. The upper values will lie from 50 to 62. Okay. And again, it is a 5 value thing. So again, your third value will be your median of the upper value. So in this case, Q3 will be your 58. Okay. Now we just need to calculate the interquartile range, which will be the difference between your Q3 and Q1. So your Q3 value was 58 and your Q1 value is 34. Okay. So this will bring us to the answer as 24. Okay. So now here is your answer. So the question was to calculate your interquartile range and your Q1 value. So your option is 34 and 24. Okay. So yes, it was the correct option. It is option A, 34 and 24. Okay. So we have last two questions. This is again a theoretical question. Which one of the following formula represents the second moment about the mean? Okay, so let's talk about the answer to this question. So the question was that second moment about the mean. Okay, so now let's first understand the meaning of this point. Second moment about the mean. Okay, so when you talk about the kth moment, so in this case it is second, but the general equation says kth moment. If you talk about the kth moment about mean, it is defined as 1 by n and xi minus the mean value to the power k. Okay, so this is the formula to calculate this. So now in this case, what exactly is the defining moment? Okay, so when you see, let me just erase this thing so you can see clearly. Yeah. So if you talk about this particular equation and the importance of k, Your k is changing the power of this. Okay, so whatever your equation is, if you consider it in case of second moment, then your value will be summation of xi minus mean to the power 2. Okay, similarly, if it was asked about the third moment about the mean, then in that case the value that would have been changed was xi minus mean to the power 3. Okay, so if you go back in the question, it is asked about which of the formula represents the second moment. We are talking about which part represents. So, of course, this cannot be true because this is not the form of the formula. In this case, this represents the third moment, okay, and not the second moment. This will again be wrong because this is not the part of the formula. And here is the k value 2, because this formula represents that we are talking about the second moment, because here k represents the moment which is given as 2 here. So based on this, the correct answer to this question will be your fourth option, which is xi minus mu x to the power 2, because that represents your second moment. Okay, so now we have one more question. It is a theoretical question. The second sample moment about the mean is also defined as, your options are kurtosis, skewness, variance and standard deviation.
Variance.
Okay. Yes, let's understand these four terms because it was a theoretical question. We'll just go with the concept of all the four terms that the option says. So let's first talk about the variance. So variance basically measures the average. So the formula of variance is very simple. It measures the average squared deviation of each data point from the mean. So it again tells you about the spread out of the data. So all these four values are basically talking about the spread out of the entire data set that we have. uh, it just uses different ways to show that. Okay, so what variance will do is it will give you the average square deviation value, and if the value of variance is very high, that means the data that you have is quite spread. Okay, so the values can lie much far away from the mean value, and the values that you get in case of variance will you can calculate standard deviation kind of values from the variance data, and this is one of the most commonly used ways to represent the spread of the data. Then the second way to represent is your standard deviation. So as I previously mentioned that you can calculate standard deviation using the data of your variance, and the formula is very simple. The standard deviation is basically the square root of your variance, and it will give the average distance of data points from the mean. Okay, so these two values will also basically talk about how far your individual values can lie. So it will give you the possibility of the values where it can lie far from the mean values. Okay, and it is more interpretable than variance because when you calculate the variance of any data, because it considers the square value, your units will always become squared. So this kind of value will come in the squared units, but in case of standard deviation it will contain the same unit, so it is much easier to interpret the data. So when you are plotting any kind of data, to show the differences, it is either shown the variation in the data you have, it is either shown using standard deviation or you can show it using standard error. The value is never shown in case of variance because for the same reason that the value you get is always a squared value, so your unit is always squared, so it becomes difficult to compare. Therefore, a standard deviation is the most common used way to represent the variation in the data. The third one is skewness. So skewness basically shows that which, if your data is asymmetrical, so you can have a symmetrical data, and symmetrical data means that equal part of your data lies on the left side and the right side of your uh, mean value. So this is a normal skewed or a symmetrical data. Okay, so for this the skewness will be 0. Now if you have a data which is for which the tail is more on the right side. Okay, so this is your center point and then it is going like this. Okay, so this kind of data shows skewness more than 0 and it will be a positively skewed data. And similarly, if you go on for a negative skew, you will have a large tail on minus side and a small tail on positive side. So basically the movement of your data, if your data lies on one side more than the other side, then your data is called as a skewed data, or it is showing an asymmetrical distribution, and this kind of data is negatively skewed. Okay, so now skewness basically is called as the third central moment. Okay, this part is important. It is called as the third central moment. And fourth one is a kurtosis. So kurtosis basically measure, so your skewness and kurtosis are very much related, but your skewness will only tell that which side your asymmetry is going, whether it is going on the right side or it is going on the left side, but it will not talk about whether your data had a more prominent peak or it had a more prominent tail. Okay, so when you're talking about the peak, the sharpness of so your data could be high, but then it could not be sharp. That means that a lot of values lie very close to mean, but they are not exactly near mean. On the other hand, if you have a data which is very showing very sharp peak, so that means that maximum values are very close to your mean value. Okay, so when you're talking about the sharpness of the peak or whether your tail is far, or you are comparing the difference between your sharpness and the length of your tail, that kind of value is calculated by a kurtosis value. So if you have a high kurtosis value, that means that data will have a very sharp peak but will have very heavy tails. Okay, so this kind of data is called as leptokurtic. Similarly, if you have a low kurtosis value, that means that it will have light tails, but the peak will also be flat. So it will not have a sharp peak. So this data is called as platykurtic. And similarly, there is normal kurtosis, which is called as mesokurtic, where the data will be in a very balanced form, where you will have a peak and in similar ratio you will have the tails as well. Okay, so normal kurtosis is usually subtracted by 3 value. Sometimes this gets asked in some objective type questions, that what is the exact value of mesokurtic data, and the answer should be 3 to this. And there are different formulas to calculate this, and this is also called as the fourth central moment. Okay, so now coming back to our question, your variance basically it is defined as the second sample moment about the mean, and therefore the answer to this question would be variance, which is your third option. Okay, so yeah, we are done for today's session. If there are any doubts or if there are any suggestions or anything else, you can ask. And if not, we can end with the session, and we'll meet again next week on Friday. Okay, if there are no doubts, then maybe we can end the session.